Good afternoon, Professor. I am pleased to present to you our project called Mesh, a pioneering step towards the future of smart home technology. My name is Rayson, and I'm here to introduce an innovative solution designed to seamlessly integrate traditional home appliances into a smart home network, revolutionizing the way we interact with our living spaces. In the current landscape of smart home systems, a significant challenge persists: the integration of traditional non-smart appliances. Many households are filled with devices that are functional and essential, but lack connectivity. Replacing these with smart alternatives is not only costly but also environmentally unsustainable. This presents a barrier to achieving a truly connected smart home environment. Our project introduces a novel smart home architecture that bridges this gap. By leveraging IR-enabled microcontrollers, we can mimic the function of traditional remote controls, allowing these regular appliances to be controlled remotely without the need for replacement. This approach is both cost-effective and eco-friendly, preserving the functionality of existing devices while bringing them into the smart home fold. As we delve into the core of our smart home solution, it's clear that each feature is meticulously designed to address specific user needs. From upgrading your beloved traditional appliances for smart home integration to controlling them through a user-friendly mobile app, our system is built to revolutionize the smart home field. The mesh network infrastructure and MQTT broker are the technical backbone, ensuring that your commands are executed smoothly and reliably, no matter the scale. Together, these features form a harmonious system that brings not just smart technology, but a truly intelligent and intuitive living experience into your home. Now, I'll be passing on my time to Ryan to talk about the project architecture.
Let's go through the project architecture, beginning with the user. The user interacts with the dashboard to control their desired appliance. Next, the dashboard sends the control command to the MQTT broker. This command is received by the master node, which in turn relays it over the mesh network to the designated node. Finally, the node executes the command using the IR transmitter. Now I'll discuss the individual components. The smart home dashboard offers users a convenient interface to manage their smart appliances seamlessly. It is a mobile app featuring a customizable dashboard tailored to accommodate various types of devices and commands. To ensure smooth communication between the mesh master node and the smart home dashboard, we utilize an MQTT broker. In our setup, we employ the Mosquito test server, enabling remote access to smart home appliances even when users are not on the same network. The mesh master node acts as a bridge between the mesh network and the internet via an MQTT broker. It receives payloads from the smart home dashboard and relays them to the mesh network. To handle MQTT operations, it relies on the PubSub client library. On the other hand, the mesh node decodes messages from the mesh network and operates appliances according to the commands received. It employs the IR remote library to manage appliances with infrared capabilities. Both of these components run on an M5 Stick C+, utilizing the Arduino framework. They also depend on the Painless Mesh library for mesh networking functionalities. I'll now pass on the time to Joshua, who will talk about the setup.
For the setup of our mesh network, we will need a mesh node master as well as the mesh nodes. First, we will turn on the M5 stick that will be the mesh node master. Upon turning on the mesh node master, the M5 stick will start to connect to the Wi-Fi and the MQTT broker. Once it successfully connects to the Wi-Fi, the M5 stick will display a successful message for connecting to the Wi-Fi as well as the MQTT broker. After that, we can turn on the other M5 stick for the other mesh nodes, and this node will connect to the mesh network and display a successful connection message. After the mesh node has been successfully connected to the mesh network, we can bring the mesh node to our desired appliance that we would like to control, which in this case is the TV.
Here is a breakdown of how a command from the dashboard on the user's phone is transmitted to the TV. The mobile phone first publishes an MQTT message to a topic in the online MQTT broker. As the mesh master node is connected to the internet and is subscribed to that same topic, It receives the message from the MQTT broker. The mesh master then identifies the device that is tied to that message. In this case, it is a TV. As this is a mesh network using the painless mesh library, the message will be sent to the desired mesh node through the shortest path. Upon receiving the message, the mesh node then runs the command through its IR sensors, which ultimately controls the TV. This is how IR devices can be made smarter through the use of IoT and the internet. Now Yaotek will be showing a demonstration of the device being used.
So this is our device in action after it has been successfully set up.
Okay, when you're ready.
Oh, we're ready.
Yeah. Okay, when you're ready.
So what's going on over here is that the MQTT dashboard is sending a message using through the broker and onto the mesh master. So this message is basically to tell the TV to turn off. So this will be communicated from the mesh master to the mesh node. So the TV will be turned off. So to conclude, our solution saves energy, enhances convenience, allows for real-time control and customization with different devices, makes it easier to set up IoT devices using the MQTT dashboard, and it allows for faster transmission of data. So our future prospect is we'll try to make it more scalable, which consists of a lot more devices, more than just currently with only like the TV, aircon, fan. We're looking to have a lot more appliances in the mesh network, and we also look to making it more efficient and a lot more faster in transmitting data. Well, that's all for the presentation. Thank you for your kind attention.